All right, so let's look at how we would write an equation in slope-intercept form using a graph. All right, so this is one of the representations we might have of a slope-intercept line. So the very first thing we're going to do is we're going to determine if the slope is positive or negative. All right, so that's going to be our first step. We can use to do this slope man. All right, so let's go ahead and draw our slope man. Remember, if it goes up, if the line goes up, it is positive. If it goes down, it is negative. A vertical line is undefined, and a horizontal line has a slope of 0. All right, so using slope man, we can see that we have a negative slope. So we'll go ahead and annotate that. We'll just do a little parentheses with our negative sign. All right, so we know that we're going to have a negative slope. The next thing we're going to verify is our y-intercept. All right, that's the point where the line of the graph crosses the y-axis. Remember, our y-axis is our vertical axis. We can see that this point occurs at 3. All right, so the ordered pair for that would be 0 and 3. All right, x would be 0 because we are still on the y-axis. So now that we know our y-intercept, the next thing we're going to figure out is our slope. So there's a couple ways we can do this. We can do the slope formula or we can do rise over run. All right, so let's start with the slope formula and then we'll check it with our rise over run. So I'm going to use the y-intercept here at 0, 3. I like to use zeros. It helps me when I'm subtracting. And then the other coordinate I'm going to use is going to be down here at 6, 0. Right, remember our slope formula is m equals y2 minus y1 over x2 minus x1. All right, so we're going to go ahead and label. We'll label the 0 and 3 as x1, y1, and 6, 0 will be x2, y2. Once we've labeled, we're going to go ahead and substitute these numbers into our formula. So m equals y2, which is 0, minus y1, which is 3, over x2, which is 6, minus x1, which is 0. So we substitute and then we simplify. So 0 minus 3 would give me negative 3. All right, that's so far so good because remember we do have a negative slope. 6 minus 0 would be 6. All right, I can simplify this fraction. I know 3 over 6 is equivalent to 1/2. So negative 3 over 6 would be negative 1/2. All right, so that's the slope I got using the slope formula. Let's verify that using rise over run. All right, so when we're talking about rise over run, remember rise is the vertical movement, so how we move up and down, and run is how we move side to side along our x-axis. So starting at our y-intercept, we can see that we have pretty points here, here, and here. Remember, pretty points are ordered pairs where we can tell a distinct x value and a distinct y value. All right, so we want to see what our rise and our run is to go from the y-intercept here to our next pretty point. So we can see we're going to go down 1 and over 1, 2. Down would be the negative movement. So down 1 and over 1, 2. Down 1, 1, 2. All right, and we can even go one further. Down 1, 1, 2. All right, so that's an excellent way to verify our slope. So now that we know our slope and our y-intercept, let's go ahead and substitute those into our formula. Remember, for slope-intercept, we use y equals mx plus b. X and y are any ordered pair that fall on this line. So our b is 3 and our slope is negative 1/2. So if we're rewriting this, we would do y equals negative 1/2 x plus 3. And that's how you write an equation in slope-intercept form using a graph.